Hey, welcome to Linaro's Opti webinar. I'm Bill Fletcher from Linaro EMEA Engineering. This webinar is entitled TE kernel support is now upstream and what this means for open source security. I'm based in Cambridge in the UK, at Linaro's headquarters. I've got Linaro colleagues on this webinar today who'll talk from the standpoint of the Linaro Security Working Group. So if we make a start, just wait for the slides to move on. So during this webinar, we'll be running a couple of polls. First of all, we'd like to know if the audio quality is good for you. So if you could click on the poll, which appears on one of the tabs in the webinar tool, and let us know if you can hear everything okay. It's getting a few sponsors in there. That's great. So good, the tool is working. And we do have chat running. If you've just joined the webinar and you'd like to maybe just check it out, then feel free to type the name of the city or the country that you're joining from. We'd be interested to see. So I'd like to introduce today's webinar subject, which is Trusted Execution Environment, a software isolation environment for executing security applications. We're going to talk about an implementation which was originally based on ARM TrustZone technology for hardware isolation between the trusted and non-trusted worlds. And there's a little diagram on the slide, which I hope you can see. We're also going to be talking about an open source project, which is hosted by Linaro. That's at opti.org. And we chose to do the webinar at this time because the driver source for the TEE has been recently accepted upstream for the 4.12 Linux kernel. And that's something we're really excited about and we really want people to share with. So if we just move on to the next slide, and who is this webinar for? This webinar is for members of the software development community. So that's developers, managers, architects, product owners, people who are developing secure applications under Linux, people who are contributing to open source, people who are working in the ARM ecosystem, people who are interested in upstreaming, and anyone with supported hardware. On the previous slide, there are a couple of boards that you might recognize. So if you've got one of those boards, great. Then you have a board which can run Opti. And even if you don't have a target board, then we do have a route to emulate Opti with QEMU, so you can get started right away. So what we'll cover in this webinar is a background on Opti. We'll look at the components that make it up. We'll look at the design principles behind it and why it's important. We'll look at how the code got upstream into the kernel, and we'll look at how to get involved. Now, one key thing is that it's a webinar, it's interactive. We hope that the value that you get from this webinar is from questions that you ask in real time and we answer to the best of our ability. So there will be a Q&A at the end of this presentation. You can raise a question at any time as we go along in the chat window. We'll try to answer as many questions as we can at the end of the presentation. It does help us if you can mark a comment as a question rather than chat. There's a little graphic there to show you how to do it. So please pitch in the chat window and keep some good questions coming. So without further ado, I'd like to move on to introduce today's presenters for the webinar. And they're from Linaro's Security Working Group. They are Joakim Bech, security expert, head of the group, and Jens Wiklander, who is the Security Working Group engineer, and he's the author of the Upstream driver. So I'd like to hand over right now to Joakim to kick off the technical part of this webinar. Thanks very much.
Thank you, Bill. I hope you can hear me too. So, yeah, as Bill mentioned, this webinar was a little bit about spreading the news about getting the TE framework into the kernel 4.12. and also give people a chance to ask questions about the work we have been doing with the driver and so on. So on the next slide, I'm going to start with Opti. And the reason for doing that is I would like to give you some kind of context to why we have been working with this T driver and how we are working with things on a daily basis and so on. So a short introduction to Opti here. It's just 4 slides now, and usually I have 20, 30 slides something when I talk about Opti. So this is a very compressed form. So Opti is an open source trusted execution environment. It's a global platform-based T, so that means that we conform to the specifications developed by GlobalPlatform. It has origins in a proprietary T solution coming from ST. So if we look at the timeline, we started in 2010 when this was starting to be developed by ST Ericsson, and they developed it for roughly 3 years. And during that period, they were also taking part of GlobalPlatform compliance testing on a few devices. And then they ceased operations in 2013. So ST took over the ownership of the T driver. And at the same time, roughly, Linaro started to thinking about forming Security Working Group. And one of the major tasks that we had in front of us was working with making T less fragmented than what it was in the past. So in the end, we started working together with ST on the T solution, and we rewrote the build system, we re-implemented a monitor, we added libtomcrypt as a crypto library, so we replaced some things that we, for license reasons, you couldn't keep it in the old, from the old solution. Then in the summer of 2014, we published everything on GitHub, and it's been there since then. Everyone can access more or less everything. There are a few components that are under NDA, for example, Widevine related things, but otherwise everything else is on GitHub. You can find everything. And by the end of 2015, we transferred the ownership from ST to Linaro. So today, Linaro both own and maintain Opti. Next slide, please. And the question is, where do Opti run today? And you can find it running on a mix of both ARMv7 and V8 devices, both 32 and 64 bits. And we tend to work mainly with development devices, and I listed a few here: Juno board, Raspberry Pi, HiKey, and so on. But we have members and non-members using it also in tablets, mobile phones, set-top boxes, and even cars today. And I took a screenshot of the platform supported on GitHub, and you can see here is roughly 20 different platforms supported today. And it's everything from devices that are publicly available to things that you only can get access to if you are partnered with the company itself. And we know quite a few other platforms also that are running on Opti or using Opti in one another way today, but they haven't upstreamed it for one another reason. In some cases, it could be licenses. It could be that they have a new product being developed and they don't want to talk about it publicly yet. And yeah, there could be other reasons also. But in general, we try to encourage people to, as soon as you can, try to upstream it, and we will get it into the regular releases and so on. All right, so next slide, please. A question that quite often comes up is about some kind of certification. And since Opti is a global platform-based trust execution environment, people quite often ask about this. And the thing is that you can't certify or qualify just the software. You always do that as a combination with both software and hardware. So that puts us in a situation here. Since Linaro, we're not manufacturing any devices on our own. We are using the devices from our members. That means that we are not actively taking part of any certification scheme ourselves in Linaro, but the members of Linaro that are using Opti, they are the ones that are active in this. And here I've listed the two areas, as I call it, the proprietary area and the open source area. And during the first era, ST Ericsson was involved in doing some compliance tests. And as I mentioned a couple of slides ago, they passed this in 2013. So, but the older this becomes, the less value it has. But it has been through some compliance tests in the past. And at the same time, GlobalPlatform, they have developed a test suite which people are using as some kind of pre-test to be able to get prepared for the compliance and qualification test. And we know that quite a few of our members are running this on a regular basis. And it happens also that they find issues, and quite often they send back patches to us, or we do patches when they have described the problem for us, and we're all good to go again. So we don't really know if this will change or not, if we will get involved in some compliance test or qualification. We have been discussing our audits, just reviewing the code and so on, but that's a little bit different. So it's not really the same question here. So, all right. So what kind of software do we have in Opti today? So this is the classic picture you have when you show a normal world, secure world, and the user space and the privileged mode. So on the left side, we have normal world, and I guess most of the people here today know what that is, but that's the normal environment where you're using Linux, basically. So user space is a normal program that you run. And in user space, we have Opti client, which is the library that you're using to communicate with the trust execution environment itself. So you have all the functions to open session and context, invoke commands, and so on. And in the same Git, we have a daemon running, which we call tsupplicant, and that is something that is used to serve secure side with file system access and a few other things. We also have the Opti test, that is our host application for the test suite that we call X-test. X-test itself is rather big today. It's standalone, and you find everything in GitHub also. It's when you run it with all tests enabled, you get more than 40,000 different sub-tests performed when running everything. If we go down the stack, we have Linux kernel, and that's mainly what this is about today. We have the T framework itself, and of course we are our own Opti driver. And further down in the stack, the secure monitor on V7, you will find the monitor in OptiOS. But if you're running on V8, then we're using the secure monitor from on the firmware project instead. On secure side, OptiOS, this is where we have all the main secret sauce. I would say that this is the big part of Opti. So you can see it as some kind of small operating system serving trusted applications with access to secure features. We have the cryptography, secure storage, secure time, and so on. So that's the big thing that we have. And on top of that, we of course have the trusted applications. And in our case, you will find a few trusted applications in the test suite, and we also have a few trusted applications just for people to get started. So this is the entire stack where we have components in Opti. So I think we can move on. So just a reminder here, if you have any questions, as Bill said, feel free to send them in the chat, and if you can, mark them as a question also, and we will try to answer it later on. And from now on, I will continue with the T generic framework. It's been accepted for kernel 4.12, and we're quite happy to have it in the kernel. I mean, it took quite a while to get the patches merged. I will talk a little bit more about it later, but it took almost 2 years from we sent the first patch set to it finally got accepted in the kernel. And we are going to give some kind of high-level overview here of what it is and so on. So no deep technical discussion here right now. So the first question is, why should we have a T framework in kernel? And kernel is everywhere. So by having it in the kernel, it will automatically be exposed to basically anything running Linux. And another benefit is that the source code has been reviewed quite thoroughly. I mean, they're coming from a world not working with open source. I've learned to see some differences. And my comment here is that kernel experts are not as nice as your corporate friend. I mean, they're nice guys, but they're also very honest. So if they don't like what they're seeing, they will tell you that this is no good. You need to change it. So as an end result of this, the final code is usually quite good. We have the maintenance. When you get it merged to kernel, someone will maintain this code for you. And there are kernel maintainers. In this case, it will be Jens that is on the call today, who will be the maintainer for this new framework and so on. We will, of course, try to run it when we are doing the Opti releases and so on. And when it comes to free as in paying someone, this is the work that has been sponsored by the members of Linaro. So we're very grateful to have them doing this for us. Another thing that we know is that the SoC vendors, OEMs, they prefer to have single tree to pull everything from. It's more work for them if they need to pull patches from a lot of different trees and they get into all sorts of merge issues and so on. So having it officially available in an upstream tree is something that they really like. So that's what we try to do. And then what are the use cases? What are use cases? Is it only DRM? And the answer to that is no. Most of the people think about DRM when they hear about trust execution environments and so on. But there are more use cases. You can have hard drive encryption, for example. How do you deal with the keys? You maybe need to authenticate the device for one or another reason. There could be existing frameworks in kernel. For example, we have something called IMA, Integrity Measurement Architecture. Today it uses TPM, but we think you could use a T if you want to instead, and so on. So there is more things to it than just DRM. But in the end, why a T framework in kernel? It is about unifying the T protocols. And that leads to this particular slide here. So GlobalPlatform. GlobalPlatform have been doing tons of good stuff for the T ecosystem, and they are continuously working with making more standards and specifications and so on. So they're doing really great work and so on. But the thing is that they haven't defined anything about the layers in between. So if you look at it, the image we had, and I've also tried to make it visible here, they are mandating how you should talk to the T from user space in normal world, and that's the so-called client API. And on the other end, you have the trust applications. They also have a well-defined API how to communicate with the T itself. But for the communication in between, there is nothing being said how that should be done. So this is the first step, trying to make something that could be used in a more common way between different T vendors here. There are more to do to it, but this is a start. So the answer is that the T driver is not a global platform T driver, and the framework is not a global platform framework. But Opti, as I said, is a global platform T. So how do we do it? How do we manage with it? The thing is that we have put everything on a higher level. So the protocol that we are using is put on top of this instead. So we have our own protocol in this case. So that was a quick introduction to that. And if we jump over to the design principles, so we have tried to not make it too big. Keep it small and simple. So you will only find a few IO control calls in the driver today. And we came up with those after having discussions both internally, people at ST, and we talked to some people that used to work for other T vendors also. So we concluded that this small set of IO controls is what you need to have when you're communicating with a T. Eventually it will be extended in the future, but this is what we have right now. And the idea is that the driver and the framework, everything you're sending to it, the information, data, and so on, that should be opaque to the driver. So it should just work as some kind of transport layer between normal world user space and the secure side. And another design goal we had was that we should reuse the existing infrastructure in the kernel. So we shouldn't try to invent our new types and so on. So we have tried to reuse as much as possible. And another requirement was, of course, to having multi-core support. And that is how it's working today. You can run it on all cores independently. So the thing is that a T driver uses this new framework. And today, it's only Opti that use this new framework. And we hope that there are more vendors trying to do this in the near future also. Next, thank you. So the first IO control we have is diversion. And you use that to identify a specific T. So if you're running RT, you will have Opti, you can have a Qualcomm's QC, you can have TrustZone's T and Trusty or whatever. So this is what you use that for. And you can also tell what kind of capabilities you have in your T. What kind of functionality do you actually support? So in this case, we have a specific listed here for Opti capabilities, and we also have one for GlobalPlatform in this case. Next slide, please. So in the GlobalPlatform slide, I mentioned that you will see quite a lot of ideas coming from, even though it's not a GlobalPlatform framework, you can see ideas coming from it. And here is one good example, the session handling, when you actually open up the logical channel between user space and the trust application. So you have two functions here, one to open the session. When you do that, you go all the way down through the stack over to the secure side and to the trust application, and you open the channel, and then you keep it open until you decide to not use the trust application anymore, and then you close the session in this case. So, and we think that this is something that is needed for any T vendor, and it should be something that everyone is using. Jump to the next slide, please. For the commands, there is a cancel command. I mean, it could be that you need to abort some ongoing operation, and that is the way how you should tell the T to stop doing what it's doing and return back to user space. And then we have the invoke command. That's the big command that is actually doing the real work. So when you have opened a session and so on, you are intended to send invoke commands, and you do that by telling what kind of trust application you intend to run, and you usually do that by some user ID or UUID. And you also have some well-defined identifier for the function that you're going to call. And we believe that this is the way that most of the people are using or communicating with trust execution environments. So I don't think this is something unique for us. But the thing is that with the limited set of IO controls that we have today, there could be a need for quite big changes in some cases. So I tried to look the other day for other drivers to see what they had. And I could see, and if we have people from Qualcomm and TrustZone here, please correct me later on, and I will correct this when we send out the slides and so on. But I found this TrustZone T driver, and I found 17 IO controls. I found a Qualcomm QC driver, and they had more than 30 different IO controls. So what they need to do instead is to bring everything down one level and tunnel it in the invoke command instead to do this. The final two commands that we have are the IO controls for the supplicants. And the supplicant is something we also believe that all T vendors have in one or another way. And the supplicant, as I mentioned in the beginning of the talk, was that you have some kind of daemon running in normal world, user space, serving secure side with access to things that it usually don't have access to. So I've listed file system access here, RPMB, and RPMB is a really good example since in Linux, if you would try to talk to RPMB directly, then you will probably get into some kind of conflict with the MMC controller. So in this case, we're actually going all the way back from the secure side to normal world, and the normal world talks to the normal eMMC framework and so on. Yep, I think we can move on to the next slide. The OPT parts of the driver that are using the framework, of course, also needs a probe function just as anything else. So if you have a look at the driver that we have submitted now, you can see that the probe function starts by figuring out what kind of invoke function should be used. Should it be a normal SMC call or should it be a HVC call? We do some sanity checking, the UID revision and capabilities to ensure that we're running what we intend to run. We configure some shared memory. And then we're using the new framework to actually allocate the T devices. And we do that both for the clients connecting to the T, and we do it for the supplicants also. And in this case, the probe function will not be called if there is nothing in the device tree blob. So on the right side here on the image, you can see how it will look like when it should be probed. And with all this in and compile and so on, it will automatically probe the driver and it will be ready to run when you boot up. All right. And once again, I just want to remember about please ask questions. We will try to ask them when I'm done with this. So, challenges upstreaming of T framework. The driver and framework that you will find today in Linux kernel, I think that is the fourth version of the driver and framework that we are writing. It was written twice at ST Ericsson and ST. Actually, 3 times. Twice at ST Ericsson, once at ST, and then Jens rewrote it more or less entirely. And now when we upstream the driver also. So if we take that, then we actually have been working with this driver for 7 years. But if we just include the work when Jens started submitting the first patch, we are talking about 2 years ago. So beginning of 2015 was when we sent the first patch set. And 16 revisions later, it finally got accepted. And why did it take that much time? Yeah, one reason is that the T framework is or T solution is not only a T driver. It spans, as I said, over a couple of different layers. So just by reading the code in the T driver and T framework, it could be hard to actually know what's going on if you don't not into this already. And in kernel, there are a lot of experts, and they know every detail about everything, but there aren't that many security experts. So it was a bit hard for them to see all this code coming and to give their opinion and view if it was good or bad. Another thing that we've seen is that getting people to review was pretty hard. We have good contacts with all members in Linaro, and we try to remind people and so on. But in some cases, there could be corporate policies saying that you're not allowed to reply to a mailing list with your company name. And in some cases, people are allowed, but they don't really know how to do it. So if you're not subscribing to a mailing list, you can still reply using email to this mailing list. But it is a little bit complicated. You need to download a patch using a web tool, and open it up in your email program, and it could be a little bit tricky. So getting people to review was actually a bit hard. So, but we had a quite nice reviews at the end, at least. We also faced the chicken and egg problem. There is some kind of mentality in Linux that you should submit early, submit often. So small patches and send often instead. But at the same time, one of the main maintainers, he told us, you must have enough code so you can actually prove that it is working and someone is actually using what you're trying to submit. So we were forced to actually include quite a lot of patches. And I think this also was one of the reasons why it was hard to get people to review it, since there was a lot of code actually in the initial patch set. And at the same time, as we've been doing this, we have been working with our kernel features. So we have been forced to keep our features we have been working with on separate branches. And those are features that we are going to try to upstream as soon as possible now. So we have a big list of patches out of 3 that we are going to try to bring in now and submit one by one. And finally, getting enough input from our T vendors. As I mentioned, we talked to some people that used to work with our T vendors and so on, but we would have hoped that we would get more feedback from more people. But with the driver in the tree now, we hope that people will stop paying attention to it and give the feedback on mailing lists and so on. So then we are closing to the end. And if people are interested in contribute to this driver, if you've never done anything before, then I suggest that you try it out. You can try it out with Opti, for example. And if you're already a T vendor, please have a look at the mailing lists. And when we are sending patches, review them, give feedback. And if you can, try to rewrite your own driver to use the new framework. And again, I remind you about reviewing patches. It's always important. There's always lack of people reviewing things. The question is, should you talk directly to Linaro people or not? If it is about Opti related, mainly, then sure, why not? I mean, you can reach out to us, email, you can go to GitHub, whatever, IRC, and so on. But if it is about the T framework in Linux kernel, please use the kernel mailing list instead. That's the traditional way of communicating in Linux. And the list that you should subscribe to in that case is listed here on this slide. So I think that should answer the question how to contribute. And final slide. The first slide had a question. What does this mean to open source security? As I tried to say, we are trying to help out unify the 3 protocols. Again, GlobalPlatform have done tons of good work with the ecosystem for T, but there are some gaps in between that needs to be filled still. Fragmentation, we have a couple of players now, and they're not really compatible. I think from a GlobalPlatform point of view, if you try to compile a trust application for example here, TrustZone, take an Opti trust application and compile it with the TrustZone toolchain, I would imagine it would work without too many issues, and vice versa and so on. But then we have some players like Trusty, for example, with Google. They're not using GlobalPlatform, so we have some fragmentation going on still. And we are trying to do some work to mitigate this and getting people to use the same kind of protocols in all different levels. And finally, we have a common code base. It shouldn't matter what kind of T we're working with. All our components in Linux, they are sharing some kind of generic framework. It doesn't really matter what kind of subsystem they are in. There are some kind of framework, and we shouldn't be different. We should also be able to share some kind of framework. And now we have code in kernel that can be shared between people if we want to. So that's everything I had. And now we're going into the Q&A. I don't know if you, Bill, want to say something here.
Yeah, hi, Joakim.
Joakim.
That's great. Thanks very much for a great presentation. So we're going to move into the Q&A now. So just a reminder to use the chat window to post some questions. We have had some really great questions. It's great to know that there are some people who are obviously quite deep into this topic, and we are seeing a lot of good questions there. If we don't get a chance to answer the questions now, then we will get back to you offline by mail. So just keep those questions coming. Whilst anybody's tabling a few last questions, just a few quick words about Linaro. So Linaro delivers engineering effort to develop key technologies for the ARM ecosystem. We develop lots of key software technologies. Some of them are listed below on the slide. We deliver our output to members, into open source projects, and into the community. You can check out our websites and projects which we host and support. And again, as some are listed there. And Linaro works with its members to maximize the return on their open source investment. So with that message done, we'll go to the questions. I'd like to kick off with the first question, which is a great one. So thanks for whoever submitted it. And it's a good place to start, which is to Joakim and maybe Jens. What is the best way to get started with Opti?
Right. So the answer to that question is go to GitHub, try to set up a complete build using QEMU, and you can do that. You don't need any hardware at all. You can do everything locally on your computer, and you can have a full environment up and running. So get QEMU, build everything, run Xtest. When you know everything is working there, you can try out the Hello World application. You can try to modify it, change it a little bit, and so on, so you get used to how to compile it and so on. And other than that, I think you should also try to look up the presentations that we have had at Linaro Connect during the years. There are quite a few presentations related to Opti.
Great.
Yeah,
that's great. Thanks. So I've taken a couple of questions that I think we should maybe take together, which are related to memory. So first question, which is, can you elaborate about memory access procedures from TE and where to configure the memory for the TE environment? Who decides that, the bootloader or TE OS itself?
Yeah, we have basically you define on the secure side the memory that you can use. But quite recently, we also added some patches that enables you to use basically memory from normal world user space. So it depends on what kind of memory we're talking about. We have the concept of shared memory when you're sharing the memory between normal world and secure side. So that is what you, for example, can use normal world memory for today. But on secure side, you have the SRAM and so on, and that's configured separately for each platform. Jens, do you want to fill in anything here?
No, I think that's good.
Yeah.
Oh, okay. Then we have a question. Do you have an interface for the kernel driver to access this firmware? Maybe you need to read something into that question.
Yeah, that's an example of one of the things that we have been working with at the same time as we were trying to submit the driver upstream. So we have out of pre-patches consisting of a kernel interface that more or less reminds of the interfaces that you have from user space. So that is something that probably will be submitted sooner or later.
Okay, we have a question. How much of the GlobalPlatform test suite testing depends on the hardware?
Good question, since we don't have access to the test suite. As I said, let's try to clarify here a little bit. So when we are testing Opti today, we are running what we call X-test, and that's a test suite developed by ourselves. And as I said, there's quite a lot of tests in it, but it's not the same as running the test suite from GlobalPlatform. So what we have done is that we have enabled it so it's possible to extend the test suite to also include the tests from GlobalPlatform if you have access to their test suite. And that's what I said in one of the slides, that some of our members are running this on regular basis. Yeah, maybe not precisely an answer to the question, but.
Okay, thanks. So the next question, is a hardened trusted Linux OS supported? Actually, the question is what exactly is supported? So the question goes on to say TZ APIs, which I assume is TrustZone APIs, and then a container framework.
Container framework, if we're talking about containers from Linux, no. I mean, this is just running directly on the hardware. I mean, from Linux side to the secure side as a single operating system. I know there have been questions in the past asking if it would be possible to run more than one T. Maybe, I don't know. We haven't seen it, not what I'm aware of.
Okay.
Yeah, a hardened Linux OS as such. I mean, it's, as I said, the driver itself is not really, it's just moving information from normal world to the secure side. So adding hardened security to the kernel, of course, helps for the overall security. But the trust model is that we normally don't trust normal world. We don't even trust Linux kernel. We see that as a non-secure thing.
Okay, so a couple more questions. We have some great questions, so trying to get through as many as possible. So again, on things which are supported, does Opti feature a secure file system?
Yes, we do, but we piggyback on the Flash in normal world in Linux. So what happens when you store something is that a trust application that would like to store some kind of information will call some secure storage functionality. You will get sent back from secure side using the RPC messages to normal world, and normal world will store it on the file system. And since this goes from secure side to non-secure side, everything needs to be encrypted and integrity protected. So we're running AES-GTM on everything here.
Okay, a couple of questions about execution model. Do you support SMP, and is Opti multi-threaded?
Yes, I think that's the short answer.
Okay, great. That means I didn't get a chance to type the next question. So just a quick answer of mine to some people who've asked. We will be sending out a link to this content. So we are recording this. We'll send out a link to the content to all the people who've registered. Some people have asked, will we post this content otherwise online on our YouTube channel? To be honest, we haven't figured that out yet. Probably ultimately, but initially we just plan to make it available to people who registered, and then it will end up on our YouTube channel, and the slides will end up on SlideShare. So again, great questions. Just looking down for the next one. So a question. Just give me a second to send it to you, Joakim.
So I can elaborate a little bit meanwhile on the multi-threading. I mean, when we're talking about multi-threading here, it's possible to run multi-thread, I mean, in secure OS context as such, but it's not possible to run threads from a trust application. And that's a misconception sometimes from people. And this is something that is it's defining GlobalPlatform also, if I'm not wrong, that you should not be able to run Trust applications with different threads.
Okay, so there was a question, how is multi-core handled in the communication driver? Are CATA sessions tagged by a core ID affinity, for example?
I think I hand that over to you, Jens.
Sorry, I need to read the question again because I missed some of the last words. Oh,
So
there it is.
how is multi-core handled in the communication driver? Are CATA sessions tagged by core ID affinity?
Yes, you could more or less compare it with a normal function call within the kernel. So you use the task context inside the kernel, and everything is tracked on that. When you do the actual SMC into secure world, it happens on the same CPU. I mean, you enter secure world with the same CPU as you did the SMC with, and when you return out on the same CPU. So any rescheduling happens in non-secure world, but it means that during one invoke you can get rescheduled by delivering an interrupt to a normal world and re-enter on a different CPU later on.
Okay. The next question, which I just posted to you, which is, if I have to do AES encryption using TE services, is there some example of how to use the invoke IOC, or generally are existing applications available? Question goes on, I remember X-Tests having some demo cases. So I guess this is application example of how to use it. Joakim?
Yeah, true. I mean, if you look in X-Test, you can see how we invoke things and so on. But X-Test is a little bit, it could be a little bit hard to follow. I mean, if you're not used to it. So I would suggest in that case instead, I mean, to call AES encryption isn't really different to calling anything else. It's just that you come up with some trust application that you're working with. I mean, you implement your own trust application. You call that trust application with a certain function ID, also invented by you. And what happens in the trust application is up to you. And that is where you actually call the AES functionality. And in OpT today, you should look at the GlobalPlatform specifications, the internal core API, to figure out how to do AES calls and so on. And I think it could also be a little bit tricky, I mean, to figure out all the calls. There are some preconditions that you need to do to set up the context and so on. But I think people in general will figure it out. And if not by doing it themselves and not by reading X-Tests, reach out to us and we will help you out.
Great. Next question, back to memory. Is it possible to allocate a chunk of RAM in the normal world and then turn it into a secure memory which can be used for a DRM pipeline, for instance?
Yeah, this is interesting. We have been working with something called secure data path for a while, and that is just to satisfy this requirement. What we have done so far now is that we are using the ION memory allocator for this, and we have added a new secure heap type. So that means that you can use this heap to, you set it up, and then you can use that memory to send information in DRM context, for example, video data and so on, from normal world to secure side. So you have a way of securing memory and without copying a lot of information. So yes, there has been some work done on it, and we hope that we can submit the patches for this work as soon as possible. The thing right now is that people, Laura Abbott and Summit, they are trying to destage the ION driver right now from being an Android driver to become a real Linux driver instead. And they explicitly told us to submit our patches until that has been done.
Okay, so next question is about CryptoCore. Oh, sorry, it's about CryptoCell. Just give me a... Which is in 4.12 kernel, we see a staging driver of ARM's CryptoCell driver. Is there an opinion in Opti about CryptoCell? Are CryptoCell and Opti related? How?
We're only using libtomcrypt. We have been in discussions with ARM regarding the default crypto framework now, replacing it eventually with embed TLS instead. And one benefit by replacing it with embed TLS would be that CryptoCell would probably work out of the box, I guess, in this case. So there has been some discussions, but nothing done yet. But I think you will see something in the coming months in this area. And I suspect that it will live side by side with libtomcrypt for a while until we know things are working. And then eventually we will switch. So.
Okay. Next question. Is TA to TA communication supported?
It is. I don't know, Jens, if you would like to add something here, any limitations and so on, but in general, it is supported.
Well, it works as specified in the internal API. Yeah, I suppose that's not much more to say about it.
Okay, and the next question is, do you support multi-threading for TAs?
No, that's what I mentioned just a few minutes ago.
Okay.
I'm not sure if there is anyone else supporting it either. I mean, I don't.
Actually, I mean, the question is there any TE which supports multi-threading for TAs? Which I guess the answer is we're not sure. We don't know. We don't.
We're not sure.
Okay, I have a question about secure user space. What is included here? Is that limited to the TrustZone client APIs?
Not sure if I really follow the question. Okay, I see the question now. Actually, to secure spaces. Yeah, so the secure user space. I mean, what? Now we're talking about Opti again, as I'm repeating, global platform-based solutions. So all the trust applications, when they are communicating with secure services, they are using interfaces defined by global platform for Opti. So that's it. There are some cases where we have made some extensions, and I think some of them have reached global platform also, the key derivation and so on. But in general, we stick with what's been defined by global platform. That's what we try to do.
Okay. So next question, is there any work on trusted user interface support?
Yeah, that's the tough question. We have been doing some work. We did a proof of concept running in emulators, FAP, QEMU, where we could fire up a trusted user interface. You got some keypad and you could enter some credentials and so on. But since we want to upstream everything, we don't want to have out-of-tree patches. We have a big task in front of us trying to get this done in a way so we can share frame buffers, etc., with Linux kernel, basically. So it's actually a normal world Linux kernel, which is the hard thing here. How can we share things that are being rendered with secure side? And that is something that we haven't been able to do anything about yet. And I don't really know when we will have time to dig into it again, but that is where we are right now. But it is an important use case. and we understand the need for it. So it's definitely on our radar.
Great. We're actually coming up to 5 to the hour now. As I said, for people who ask questions that we may not get to, we will follow up with you offline if we have an email address for you that works. So we will try and get in touch with you. They have been really great questions. So thanks very much for what you submitted. So a good question to come close to the close, which is, what is the future roadmap for the Linux T Opt infrastructure? What about support for client applications in containers and or virtualization?
Good question. I guess I'm repeating here. I mean, this is something that has been discussed also, but it's not really on our radar for the near future. At least not running things from a virtualized environment. So we will probably stick with doing what we have been doing right now. But I know that there are people that have been looking into this already. We had one engineer from, he used to work for GlobalLogic. He did some work with Opti and virtualization and so on. And I know there is one, it's not a company, it's, I think there's some research, they're working with it here in Sweden and trying to run virtualized environments together with Opti. But yeah, it's not really on our roadmap as such, but internally we have a roadmap. I mean, we try to, our members, we get requirements from our members, what is most important for you, and then we try to prioritize that and work according to that. And that is something that we also have on the to-do, that we need to publish a little bit more information on public pages of what's going on, since otherwise it could be hard for people to know if we already have been thinking about doing something. So, yeah.
Okay, we're pretty much out of time now. So for any questions that we didn't get to, we will try to follow up with you offline. Everyone that registered will be mailed a link to the recording and the content. Please check out other Linaro content on SlideShare, on YouTube, at linaro.org, and of course at opti.org. We will ultimately be posting this content on our YouTube and SlideShare channels. So it just remains for me to thank very much everyone for joining. Thanks to Joakim and Jens, our presenters from the Security Working Group. And thank you very much for making this webinar a success. Thank you.
Thank you.